The Earth's magnetic pole, the North Pole, is shifting rapidly, so what will happen to the northern lights, Aurora Borealis? This is by Conversation UK. Nathan Kay, Senior Research Associate, Space and Planetary Physics, Lancaster University. Like most planets in our solar system, the Earth has its own magnetic field. Thanks to its largely molten iron core, our planet is in fact a bit like a bar magnet. It has a north and south magnetic pole separate from the geographic poles, with a field connecting the two. This field protects our planet from radiation and is responsible for creating the northern and southern lights, spectacular events that are only visible near the magnetic poles. However, with reports that the magnetic North Pole has started moving swiftly at 30 miles every single year, 50 kilometers a year, and may soon be over Siberia, it has long been unclear whether the northern lights will move too. Now a new study published in Geophysical Research Letters has come up with an answer. Our planetary magnetic field has many advantages. For over 2,000 years, travelers have been able to use it to navigate across the globe. Some animals even seem to be able to find their way thanks to the magnetic field. But more importantly than that, our geomagnetic field helps protect all life on Earth. Earth's magnetic field extends hundreds of thousands of kilometers out from the center of our planet, stretching right out into interplanetary space, forming what scientists call a magnetosphere. This magnetosphere helps to deflect solar radiation and cosmic rays, preventing the destruction of our atmosphere. This protective magnetic bubble is not perfect though, and some solar matter and energy can transfer into our magnetosphere. As it is then funneled into the poles by the field, it results in a spectacular display of the northern lights. But we have a wandering pole. Since Earth's magnetic field is created by its moving molten iron core, its poles are not stationary and they wander independently of one another. In fact, since its first formal discovery in 1831, the North Magnetic Pole has traveled over 2,000 kilometers from the Boothia Peninsula in the far north of Canada to high in the Arctic Sea. This wandering has generally been quite slow, around 9 kilometers a year, allowing scientists to easily keep track of its position. But since the turn of the century, this speed has increased to 50 kilometers a year. That's 30 miles a year. That's a whopping 30 miles a year. That's a huge amount. The South Magnetic Pole is also moving, though at a much slower rate of 10 to 15 kilometers a year. This rapid wandering of the North Magnetic Pole has caused some problems for scientists and navigators alike. Computer models of where the North Magnetic Pole might be in the future have become seriously outdated, making accurate compass-based navigation difficult. Although GPS does work, it can sometimes be unreliable in the polar regions. In fact, the pole is moving so quickly that scientists responsible for mapping the Earth's magnetic field were recently forced to update their model much earlier than expected. Now, will the aurora move? The aurora generally form in an oval about the magnetic poles, so if those poles move, it stands to reason that the aurora might as well. With predictions suggesting that the North Pole will soon be approaching northern Siberia, what effect might that have on the aurora? The northern lights are currently mostly visible from northern Europe, Canada, and the northern United States. If, however, they shifted north across the geographic pole, forming the North Magnetic Pole, following the North Magnetic Pole, then it could be changed as well. Instead, the northern lights would become more visible from Siberia and northern Russia and less visible from the much more densely populated US-Canadian border. Fortunately for those aurora hunters in the northern hemisphere, it seems as though this might not actually be the case. A recent study made a computer model of the aurora and the Earth's magnetic poles based on the data dating back to 1965. It showed that rather than following the magnetic poles, the aurora follows the geomagnetic poles instead. There's only a small difference between these two types of poles, but it's an important one. The magnetic poles are the points on the Earth's surface where a compass needle points downwards or upwards vertically. They are not necessarily connected, and drawing a line between these points through the Earth would not necessarily cross its center. Therefore, to make better models over time, scientists assume that the Earth is like a bar magnet at its center, creating poles that are exactly opposite each other, that is, they are antipodal. This means that if we drew a line between these points, the line would cross directly through the Earth's center at the points where the line crosses the Earth's surface. We have the geomagnetic poles. The geomagnetic poles are a kind of reliable, averaged out version of the magnetic poles, which move erratically all the time. But because of that, it turns out they are not moving anywhere near as fast as the magnetic North Pole is. And since the aurora seems to follow the more averaged version of the magnetic field, it means that the northern lights are not moving that fast either. It seems as though the aurora are staying where they are, at least for now. We already know that the magnetic pole moves. Both poles have wandered ever since the Earth existed. In fact, the poles even flipped over, with north becoming south and south becoming north. These magnetic reversals have occurred throughout history, every 450,000 years or so on average. The last reversal occurred 780,000 years ago, meaning we could be due a reversal soon. So rest assured that a wandering pole, even a fast one, should not cause too many problems, except for those scientists whose job it is to model it. So this is by The Conversation, Nathan Case, Senior Research Associate in Space and Planetary Physics at Lancaster University. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.